Okay, we're going to look at how to find the inverse of a function. The first thing you want to do is to be sure that you have a function. Now, in our textbook and your homework, you are going to be given a function. You're not going to be tricked into given a relationship that's not even a function. Okay, so once you look at your function, you have to be sure that it is one-to-one. And then what you're going to do is you switch your x's and your y's. Now that's very easy if you have a set of ordered pairs. And you can see my example here. I am just taking this ordered pair 2, -5 and switching it around to -5, 2. Right? And then the same thing with my other ordered pairs as well. If I'm given an equation, then I switch my x and y, and then I solve for my new y. Now, the domain needs to be restricted in order to do this at times, and you will be given the restrictions needed to ensure an inverse function. I think the book goes a little bit beyond this, but we are going to, all the problems that we're going to be doing, the restrictions are already given for us. And I have an example here. I'm going to work through a couple more examples on the next slide. But you can see that I start off with a equation with y equals, and then I change that to x equals, just switching the x and the y around and then solving. So again, the first step in looking at inverse functions is actually determining whether or not the function is one-to-one. And here I have all of my y values being different, right? 6, 8, and -13. They're all different, so this is one-to-one. All the y values are different. Or, if different ways that you could say that. You could also say that the y values do not repeat. When you're given a graph, your graph needs to pass the horizontal line test. So if you can draw a horizontal line and it touches your graph in more than one place, as in this example, it is not one-to-one. In my third problem here, I am given an equation. And the way that I can determine if that is one-to-one is to graph it and then use the horizontal line test. Now, if you want to stick this into your graphing calculator, that's fine. But remember that this is really y equals x squared minus 7, and we have been working with problems like that. That is a parabola. I know that it opens up, and I don't really need to put this on a coordinate grid. I just sketch it real quick and use the horizontal line test, and I can see that a horizontal line will hit the graph in more than one spot, so that this is not one-to-one. Now with the next examples here, I am asked to determine the inverse of each of the following. So I already know that it's function. I already know that it is one-to-one, and I just have to find the inverse. So what I need to do is to switch the x's and y's. So in my set here, I have -18, 15. It's my first ordered pair. And then I'm going to have 18, -13. And then 15, -1. And that takes longer to type into the computer than it actually is to do. Right, my next problem, I am given an equation. I'm asked to find its inverse. So the first thing I'm going to do is write this as y equals x cubed minus 8. And just so I don't get confused, I'm going to write this or label this as my original equation. So now I know that I need to switch these x's and y's in order to find the inverse. So this becomes x equals y cubed minus 8. And I have to solve for y. So add 8 to both sides. So I get x plus 8 equals y cubed. Then take the cubed root of both sides. So I get y equals the cubed root of x plus 8. And then I'm going to write my final answer in function notation. So the inverse function is the cubed root of x plus 8.